Hello everyone, my name is Rishi Kumar and today I'll be presenting my project on leveraging R for enhanced detection in fibromyalgia, identifying key biomarkers through a novel application of differential expression analysis, LIMA-VUM. Fibromyalgia affects 480 million people globally, with around 15 million in the United States alone. There's a disproportionate impact on the female population, of 12 million compared to the 3 million males. Now, what is fibromyalgia? Fibromyalgia is a chronic pain disorder that affects millions of people worldwide. It is often misdiagnosed due to its overlapping symptoms with other chronic pain conditions like lupus. The condition significantly impacts the quality of life of those affected. Let's investigate what we use for diagnosis today. Diagnosing fibromyalgia can be challenging. The tender point test, which checks for tenderness in 11 out of 18 joints, is commonly used to diagnose patients. However, this test is subjective and less reliable, making diagnosis difficult. Ruling out other chronic conditions is time-consuming. Hence, there is an urgency for biomarker-driven diagnostics for fibromyalgia. While genetic factors are known to contribute to fibromyalgia, in the field of genomic research, DSQE2, a traditional genomic analysis, has yet to identify conclusive gene expression patterns. Furthermore, genome-wide studies haven't identified specific actionable biomarkers that can be used for a biomarker-based diagnosis. Additionally, sex-specific differences in fibromyalgia are poorly understood, despite evidence suggesting significant variation between males and females. I have discussed these problems, and now let's review the objectives. My study aims to address these gaps by identifying significant biomarkers, analyzing biological pathways, and exploring protective genes. My hypothesis is that I believe that the HTR2A and COMET genes will be significant, along with neuronal signaling pathways, which will exhibit differential expression in fibromyalgia patients. These patterns can help distinguish fibromyalgia cases from controls, and there will be sex-specific insights and variation between males and females. The first thing I did was I set up the necessary packages in R and for the genomic analysis. I then prepared my public PubMed dataset of 22,000 genes, 800 different patients, ranging from control, fibromyalgia, male, and female. I then performed necessary transformations and shaping of the data by transferring frames per kilobase million, FPKM, to transcription per million, TPM, for a more robust gene expression analysis. I used 3 different analyses. First, I performed differential expression analysis to identify significant biomarkers using the LIMA-VUM package to account for the mean variance relationship to reduce variability. I then created a subgroup analysis to reveal sex-specific patterns. This whole analysis is then visualized through a bar plot overlaid with a heat map. The second type of analysis is PEA. I mapped differentially expressed genes to biological pathways using the Kyoto Encyclopedia of Genes and Genomes database to find enriched pathways and then adjust the p-values to ensure statistical significance. The visual is a dot plot overlaid with a heat map. This is the third and final analysis. Gene set enrichment analysis, otherwise known as GSEA, examined gene clusters and cumulative pathway activity. Identified significant pathways using PEA and DEA results. This visual is seen in an upset plot. Now, let's review the results, beginning with trends in DEA for overexpressed genes in fibromyalgia patients. Both females and males exceeded a log-fold change of 15. This is the gene expression numerical form. I then found that the biomarkers for overexpression were similar across sexes. This indicates that specific biological pathways are universally disrupted in fibromyalgia regardless of sex. In Hugo gene symbol format, it's clearer that biomarkers overlap between sexes. Next, let's look at the protection genes identified in DA, which are the underexpressed group. Once again, the log-fold change exceeds 15. With the protective group, biomarkers overlap between sexes. Converting from ensemble gene ID to a Hugo gene symbol format, it's clearer again. We see that there's a biomarkers that overlap between sexes, but we see the same biomarkers that are overlapping with the overexpressed group. This shows that the condition's development and protection rely on the same biomarker and biological strategies. Then, pathway enrichment analysis, or PEA, allowed me to identify biological pathways associated with fibromyalgia using the Kyoto Encyclopedia of Genes and Genomes database. Unlike DA, here we observe sex-specific differences in enriched pathways. For female, neurodegenerative pathways and in males, neuronal signaling pathways were more prominent. These findings emphasize sex-specific pathways that drive fibromyalgia. For protection part, in females, protective pathways highlighted neurodegeneration as the most significant. For males, there is a stronger emphasis on Parkinsonian-like neurodegeneration. This highlights the nervous system's role in protecting against fibromyalgia's effect in males and females, and we also see a distinction in cellular maintenance, with females emphasizing cell cycle and males emphasizing the oxidative phosphorylation step. If you zoom in the highlighted section of the chart, gene set enrichment analysis, or GSEA, provided cumulative insight into the pathway activity, which is the horizontal bar in blue. Then in the largest vertical bar in blue depicts the distinct gene clusterings. There was distinct sex differences in fibromyalgia-related pathways. For females, immune-related pathways such as chemokine signaling and NETs were dominant. In the case of males, neurodegenerative pathways was again significant, further solidifying the neuronal role in fibromyalgia. For females, protective pathways included ribosomal activity and immune regulation, reflecting a robust immunal involvement in fibromyalgia. For males, GSEA identified neuroprotective mechanisms. To conclude, these insights provide a blueprint of natural protective mechanisms, offering potential for better diagnosis. I had two limitations to the study. One, the lack of clinical factors such as race, age, and demographics limit the enrichment of the dataset. The second limitation challenge was the conversion between Ensemble Gene ID to other databases. Since there's not a clear one-to-one mapping, because there's no common data taxonomy, it leads to some accuracy dilutions. This research has practical applications, as biomarker-based diagnosis could enable faster, more accurate sex-based identification of fibromyalgia, but enables patients to be on top of their treatment and management plan. 2, this outlines a methodology and analysis for conditions that are sex distinct to find significant pathways and biomarkers. The HTR2A and COMA genes were not significant. However, RN7SL1, SNORD17, and SNORD73B were common across the sexes. Neuronal signaling pathway, neurodegeneration, and immune response pathways were enriched. Overall significant biomarkers exist, however, not distinct across sexes. Gene clusters and pathways were distinct. In the future, I would like to use clinical factors to improve my analysis quality. I also want to use AI for statistical refinements and to create one common taxonomy to achieve higher accuracy and scalability. Here are my references. Thank you for listening to my presentation.